All right, problem 5-74. Every exponential equation has an equivalent logarithmic form, and every logarithmic equation has an equivalent exponential form. For example, we'll see here that we have something here written in exponential form. We have 4 to the third power, where 4 is our base, 3 is our exponent, is equal to 64. They say this is equivalent to 3 equals log base 4 of 64. So kind of pay attention to where these things exist in each of these expressions because they are the same parts and pieces just written in different forms. Our exponent, for instance here, when we're in logarithmic form, remember that exponent is by itself. Something you may want to remember. That's something that I would remember. Hint, hint. But remember base, well, 4 is our base, 4 is our base, and there's only 3 parts to it right now at this point, so that means that 64, is going to have to be located with our base here. So it's kind of like we flip-flop what's located with our base. Right here we have our exponent here, and then our output, our normal output here, it's like our 4 and our 64, which was on the outside over there, is now with the base, and our exponent's on the other side. Anyway, okay, so let's just take a look here. Copy the table shown below and fill in the missing form in each row. So, if it's an exponential form here, we have y is equal to 5 to the power of x. Remember, 5 is our base, x is our exponent. So when we go to logarithmic form, remember we just said that the exponent is always by itself. So x is our exponent here, so x ends up being by itself on this side. So it should be x is equal to log of base 5 of y. So x equals log base 5 of y. Let's try the next one here. Let's look at b. Oh, now we're going backwards. We have y equals log base 7 of x. Well, remember, the exponent is the thing that was by itself. So we already know that 7 is our base. And so we're going to say x is going to equal our base raised to our exponent, which in this case would be y. So x equals 7 to the power of y. Letter C, 8 to the power of x equals y. Well, our exponent, remember, is going to end up being by itself. So we've got x equals our log base 8 of y. And if you want to put these in parentheses, sometimes that helps. Maybe I'll do that here to make sure everybody can tell them apart there. Let's look at D. A to the power of k equals c. So we know now that our exponent in exponential form is k, so it's going to be by itself. So we have k equals log base a of c. That's our base a of c. Now coming back over here, well, k is our exponent here. And this one you can kind of look at, this is the exact same equation as the one above it here. But just know that we could also write it the other way around. We could say C equals A to the power of K. Just want to make sure that we're comfortable seeing it both directions there. And the last one here, we've got letter F. We've got log of base 1/2 K equals N. So remember, exponent is the thing that's always by itself there. Our base is 1/2. So we're going to say 1/2 to the power of N should equal K. So there are your answers. This is problem 5-74. I know this can get a little confusing and tricky, so the more you practice, the more you look at it there, the easier it does get. Remember, one of the main things that makes it easier to remember is this. When it's in logarithmic form, the exponent from exponential form is always by itself there. That's one way to kind of help you to remember what you need to do. Problem 5-74. If you have questions, make sure you ask your teacher.